This lesson is solving linear systems by graphing. When graphing linear systems of equations, there are only three situations. And there's one with one solution. That's when there's a unique intersection, a point that they have in common, the two lines. You have infinitely many solutions, and I'll give an example of that later on, and no solution, which I'll also give an example later on in the lesson. All right, so for example, graph x minus y equals -2 and 2x plus y equals 8. The quickest way to graph that is to put them in slope-intercept form and graph the y-intercept and use the slope to count over. So notice they're in standard form. I got x minus y equals -2. If I solve for y in terms of x, I'm going to move that x over to the other side. So I get -y equals -x minus 2. And I'm going to divide everything by -1. So I get y equals x plus 2. So my slope here is 1 and my y-intercept is 2. And then you want to graph the other one. You want to change that to slope-intercept form as well. I'm going to move the x term to the other side. So I have y equals -2x plus 8. I can go ahead and graph those those two. X plus 2. Okay. So look, let's graph y equals x plus 2. I'm going to start with 2 because that's my y-intercept. So I'm going to go up 2. And my slope is 1, so I can go across 1 and then up 1. Or I can go to the left 1 and down 1. And that will be my line. And you keep doing that until you get a common intersection with the other line. I can go ahead and make this line. Okay, the other one, you're going to start with 8. And your slope is -2. So I'm going to go across 1 and down 2. I can go across 1 and then down 2. And notice that when you do that, it's going to intersect there. You can stop there. And that lets you know your common intersection. And that is 2, 2, 4. Because you go across 2 and come up 4. If I were to graph that line, it'd be something like that. And that's my common point of intersection. That's called a unique solution because that's the only time those two lines will ever cross. It's just at that point, at 2, 4. All right, graph x plus 2y equals 6 and x equals 2. Again, with this top equation, you might want to put that in slope-intercept form. So I got x plus 2y equals 6. I'm going to move the x term to both sides. So I get 2y equals -x plus 6. And I'm going to divide both sides by 2. So I get y equals -1/2 x plus 3. So I know my slope is -1/2 and my y-intercept is 3. And a lot of people get confused with this. X equals 2. x equals 2 is already in the format where you can graph it. We know that's going to be a vertical line at 2 on the graph. See, what happens is this is x plus 0 times y equals 2. So you just have x equals 2. All right, so let's graph this. All right, so we're going to graph y equals negative 1/2 x plus 3. So we're going to start with the 3 on my y-axis. So I go 1, 2, 3. And then we're going to count over the slope. So I can run over 2 to the right, 1, 2, and then I can go down 1. And you can keep repeating that process. Over to the right 2, down 1. Or I can go to the left 2 and up 1. To the left 2 and up 1. And then I can connect my points. All right, in my other graph, you have x equals 2. That's a vertical line. You're going to go over to the right 2 and make a point. You can keep going up over to the right, make a point. Because it doesn't matter what y is. Remember, this is x plus 0 times y. Whatever y is, you're going to multiply that to 0. 0 times anything is 0. X is always going to equal 2. So what you're going to get is this line, a vertical line. So this is x equals 2. And this line is y equals negative 1/2 x plus 3. And if you look here, you see this is where they intersect at. And this is 2. You go over to the right 2 and go up 3. That's where they intersect at. So again, this also has a unique solution of 2, 3. All right, graph y equals 2 and 2x plus y equals 1. Y equals 2, that's going to be a horizontal line. And similar to the last problem, this one has 0 for the coefficient of x. So 0 times x plus y equals 2. Thus, you just have y equals 2. 2 is not your slope, though. That's going to be your y-intercept, if you will. But it's just y equals 2. All right, this one you want to put in slope-intercept form. So I'm going to solve for y in terms of x. All right, so what you have here is you're going to subtract 2x to both sides. So you have y equals negative 2x plus 1. That means my slope is negative 2. My y-intercept is 1. So let's go ahead and graph these. So I have y equals negative 2x plus 1. And we're going to graph y equals 2. All right, we're going to start with 1 on the y-axis. I have negative 2 over 1 as my slope. So I can run over to the right 1, and I'm going to go down 1, 2. Or I can go to the left 1 and go up 2. Or I can go to the left again 1 and then up 2. To the right and then 1, 2. You're going to get this line here. And then y equals 2. That's a horizontal line. You're going to go up 1, 2. And you're going to make a line there. But if you look carefully, the intersection is not a whole number. That's the limitation to graphing. So sometimes it's best to use substitution or elimination to get the exact answer. So something like this, you know that y equals 2. So we know that's part of the intersection. But if you want to know what x is, the exact number, you have to plug in y for 2. So let's say 2 equals negative 2x plus 1. Then I can subtract 1 to both sides. So I get 1 equals negative 2x. Divide both sides by negative 2. X equals negative 1/2. So this is negative 1/2, 2. It's a point of intersection. All right, graph y equals 2x plus 4 and y equals 2x minus 3. This is already in slope-intercept form. We know that the slope is 2 for both equations, but the x and y intercept differ. The y intercepts differ. The equation up top is 4. The y-intercept on the bottom equation is negative 3. So you get y equals 2x plus 4. And we have y equals 2x minus 3. All right, so I'm going to start with 4. I'm going to count up 1, 2, 3, 4. Our slope is 2. So I can go to the right 1 and then go up 1, 2. To the right 1, up 1, 2. Or I can go to the left 1 and down 2. To the left 1 and down 2. This will be our line. All right, then the other one is y equals 2x minus 3. So negative 3, we start here, below the x-axis, 1, 2, 3. And the slope again is 2, 1. So I can go over to the right 1 and then up 2. To the right 1, up 2. To the right 1, up 2. Or to the left 1 and then down 2. If I connect those points, notice that these lines never touch. In this case, there's no solution because there's no intersection. And the secret in that is that the slopes are the same. Notice you have 2x, 2x. The slopes are the same. You have a slope of 2. So, therefore, there's no solution there. This concludes our lesson for today.